So you know it's going to be a good time when these safety glasses are involved.
Oh boy, science lessons can be hard to learn just from books. Experiments are fun, and that's where these glasses come in.
And this guy, he's fun too. He's always got something to show,
Hey, John.
show us this morning from our local 4-H chapter. John Kilpatrick, good
Nice
to see you, John.
see you again.
Nice to see you guys.
Yeah,
again.
so what are we
Thank
going to do today?
We're going to look at some of the elements like in our kitchen science program, some chemistry, and then a little bit of electricity today. So we have three things we're going to try to cover.
Very cool. Where do we start with the first?
Yeah, let's go ahead and start off with our kitchen chemistry.
Should we put these on?
No, we don't really need those
Okay.
until we get into that, until we get into our real chemistry, and then that's going to be what we do
Oh boy.
cover eyes.
Okay.
So we're going to start by giving each person a cup, and then I'm going to give each of you a little green card, right?
Okay. So far, so good.
So far, so good.
Okay.
Right. So what we're going to do is we're going to put some water in our cups. So, oops. So we want to take the cup and go ahead and fill it all the way full. All right. And you guys can get your cups over here.
8 to 10 glasses a day, John.
All right.
All right, so far we have all of this in our kitchen.
Yeah.
Or
So that's why we
craft
call it kitchen chemistry, because
Yep.
it doesn't involve anybody going out and getting anything extra or special. But if we could all just kind of get over this little tub, that'd
Okay.
be great. And we're going to take the cards. All right. We're going to take the card and we're going to put it on top of the water in our cup. And we're going to steady that card with one hand. So put one hand on top, just like I'm doing right now. Now imagine having maybe 10 or 15 little kindergartners in this next part, because they're doing this too.
Okay, flip it over.
You take it and go like this. So all the water is going to go on top of the card. All right.
Okay.
And so what we do is we say, now we're going to take a hand off, and what's going to happen to the water in the cup? And a lot of people say it's going to drop out. And so we go ahead and just take that bottom hand off, okay? And right now, the water's staying in the cup. And essentially, we're looking at where the air is. If you look at the top of our cup, there's a small amount of air that's trapped inside, but the room, huge amount of air. And so we talk about air pressure and how air pressure pushes in all directions. And so what we're having right now is we're having air pressure push against our cards, and whoops.
And then eventually,
it falls, yeah.
You startled me.
Well, if you look at the card's a 5x5 card.
Right.
It's 25 square inches, 15 pounds of pressure per square inch is 375 pounds of air pressure hitting that card.
Yeah.
So at what point does it fall off? Just
Well,
when
you can
weigh
squeeze
the
the
water?
we can give it,
plastic
you can give it a little
cup.
squeeze. We can squeeze it to change
Yeah.
air pressure. Lots of times we use styrofoam cups, we poke it with a pin. And there's another way that we look at this too.
I want to
And,
make sure we have time for the next two. I don't
Oh,
want to
yeah,
run
sure,
out
sure.
of time here
No.
because we've got some
Yeah.
work stuff to get
Let's
to,
go and
John.
do that.
I don't
Good.
want to interrupt that, but
All right,
got
so what we're
more.
going to do is, this is chemistry, and we look at how we can identify if a chemical reaction actually takes place.
Okay.
And so what we're going to do, this is where you two need to get your
boy.
safety goggles on.
Right
all right?
on.
I'm going to
Okay.
hold some things off to the side here.
You gave me the ones that are all fogged up. These things are all fogged up. Typically how she does stuff
Intentional.
around here. That's
That's
why I
okay,
can't
as long-
see.
As long as we protect your eyes from a spill, that's the most important thing. So what we're going to do is we're going to use hydrogen peroxide. And this is not the hydrogen peroxide you're going to find in the kitchen cabinet. That's 3% peroxide. The stuff that people might use to color their hair, 6%. This is 30% concentrated.
so where do you get this stuff, John?
We ordered this through a chemical supply company. So yeah, this isn't available to the homeowner, and obviously this isn't part of kitchen science, but you're going to very carefully take your beaker of hydrogen peroxide. We're going to put it in our large cylinder, all right? And so now we have our hydrogen peroxide going into our large cylinder. Next thing we're going to do is you can pick your favorite color.
Oh.
Yeah,
In
green,
honor
I
of
don't see-
Nebraska, I'm going to
Well,
go
I
with
don't see
red.
Wildcat blue over
Wildcat
there for you.
blue. I have purple. Like,
Yeah, I was going to say we can mix the
Kansas.
red and the
All right.
purple. Okay.
All right, so just give a good shot of that right down in there.
Just any amount?
Yeah, that's
Okay.
perfect. So we can just change it, have a little bit of looking at a little bit of color to it. Now, what we're going to do, we talk about chemical reaction. Hydrogen peroxide is basically H2O2. So it has that extra oxygen molecules attached to it. So you're going to each put a good shot of dish soap right down this tube, okay? And with that, what's going to happen is when we do our reaction, we'll pass
Do I
it
need
down
more?
to Mike. Nope, you're fine.
Okay.
We'll pass that down to Mike. So when we do a chemical reaction, if any gas is being given off in this process, the soap should capture it, and we would get some foam. Now, right now, the reaction is taking place, and if we waited a week, these tubes would fill up with foam. Now, here's a chance where we get
To
introduced.
accelerate it?
Yeah, a catalyst,
There you
right?
go.
So now we have the catalyst. Now, when we do this, what we're going to do is I'm actually going to have you guys step back just a little bit on this one, right?
Here's where, yeah.
Yeah,
here's
this is where it gets
crazy.
fun. I'll get my stuff
This is
out
why
of
the
here.
entire set is covered in plastic?
Yeah, I just don't want to get these things coated because I am going to need them again. All right, so so let's see. Let's have you switch to. You can just switch this hand. You're going to pour in this side. in
We
just a
don't need
second.
plastic for our bodies or anything, do we?
No, you shouldn't. But you're going to just dump it in quick and then pull your hands right
I'm
back.
concerned
But
by your-
together. Oh, together.
together.
There you go. Whoa, there you go. All right. Now, if you look at it, we get a lot of steam that's coming off there. We can
at
also
that.
talk about energy. So this is energy being given off, or this is exothermic.
warm.
It's very warm. If we were to stick
wow.
a thermometer in there, it'd reach a temperature of about 170 degrees Fahrenheit.
So what was this? What was the accelerant?
Well, our accelerant or catalyst, this was potassium iodide. And
Okay.
so it took that reaction and it just, well, you saw. Shot the foam around it too.
Well, it's beautiful.
So it would
isn't
eventually
it?
do that by itself if you just let it sit there for a number of weeks
A
without
lot, yeah.
adding the
It'd take about a
potassium.
week and it would just kind of be
Rise
really
instead of
slow.
shoot.
Boy, yeah, it'd be a boring reaction.
Right,
So
right.
this
Okay.
way we could put a little more awe into it. All right, now you want to go down to this last one?
Sure.
Do we need the goggles still?
Oh boy.
No,
We're good.
now you can take the goggles off. And everybody's eyes are still there, so that's a good thing.
Oh, yeah, we have our eyes.
Okay,
Okay, what do we got here?
this is
I
a,
think you brought this thing in before. Have you brought this in?
yes, I
I
have.
think you have
This
brought
is
that
a
in before.
this is a Tesla coil, and the neat thing about Tesla coil is it produces a high energy charge, and at lower voltages like this one, this only goes up to about 50,000 volts. That charge behaves a little bit like static electricity when it comes in contact with our bodies, and so I thought we could try that today.
Okay.
All right.
Fantastic.
Do we keep the lights on or bring
No,
them
we can
down?
go ahead and bring the house lights down
Okay.
a little bit. All right, so we're going to go ahead and turn this on. Like I said, it behaves a little bit like static electricity, but it's not true static electricity. I'm going to go ahead and have you guys hold this light tube. All right?
Hold it.
Sure, yeah, you can go ahead, you can touch it, you can see the light tube starts to light up a little bit. And that's because this is oscillating between positive and negative voltages. And it does this thousands of times per second. When we look at this, we see a continuous spark, but most of the time, it spends its time in an off position. Now, you hang on to it, Mike, and Mary, you grab that tube also. But
Is
grab
she
that
going to light
more
up?
towards the
Because
end.
if she's going to light up, I can't wait to see
I'm going to light
this.
you both up. Now, I got Mary just put her hand right here.
Okay.
Okay, now, Mary, I'm going to turn this down. And what I'm going to have you
Should
do,
I?
just have you put your hand right here, all right? So your
Okay.
hand is right on that, cover that. And now we're going to focus on our little fluorescent tube here, and you can see how it lights up there.
Okay, now let go, Mary.
Yeah, and you can let go.
Grab it again.
Grab it again.
Yeah.
Right, and that's just passing over your bodies. It doesn't go into your body, which is a good thing. If it did, you know, then we had risk electrocution. We're not
Look
gonna
at
do
that.
So, but then if you just touch it directly again,
Yeah, touch it directly again.
And look at this.
Right,
that
and
is
you can
so
see the little
cool.
filaments that come out of it.
That's really cool, John.
I am your father.
We have a minute. I want to talk quickly about 4-H. You do
Absolutely.
experiments like this in schools all
Right,
the time.
right.
For teachers who are watching and want to bring you into the classroom, what do they need to do?
All you have to do is go to our website, which is 4hgetgreen.org, and they can click on 4-H in the classroom, and then we have a huge menu of different projects and things that we
Yeah.
can do, anywhere from grades K all the way through 8th grade.
And 4-H
just-
isn't just for kids who live in the country, right?
No, it sure isn't. Right?
yeah, doing stuff all year round too.
All year round, right? We have a very urban program.
I love that. Well, and you know, I'm a former 4-H'er here, so I
Right.
love what you do.
Yeah. Well, I was an
but we didn't do this.
I grew up in town. I went to a 4-H camp when I was younger too.
Yeah, we didn't do this though.
We have lots of camps too.
4-H, the number 4-H, getgreen.org. That's the website if you'd like to learn more about it. John, it's great to have you back on the
Thank you.
blend. We
Oh,
appreciate it very
always
much,
good,
sir.
Janet.
Thanks for
Thank
coming.
you.
Thank you.
After the
Thank
break,
you both.
5 items that will help you with this year's spring cleaning.
And Justine Santinello is covering all corners of the house for us, from home office to the garage. There she is. We'll be right back.